12.9 deals with inverse trig functions, which we need to know how to find inverses in order to solve equations. So solving equations, we will probably get into in a lot more detail tomorrow. As far as inverse trig functions go, you're going to see a terminology, but know that you have already done it. You've already dealt with this particular bit of terminology. That's known as arc. Arc sine, arc cosine, arc tangent is just a fancy way of saying sine inverse, cosine inverse, tangent inverse. They mean the same thing. The only difference is regular sine inverse is primarily when you are inside of a triangle. Arc sine deals with the fact that trig can also be done around a circle. Hence, arc comes from terminology related to a circle. So, since we're now dealing with trig going around a circle, there is another concept that does get added into this. And that is the idea that your trig answers can exist in two different places along the circle. So, for that, we're going to introduce a coordinate plane. So we still have our XY coordinate plane with quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So that part hasn't changed. However, depending on what quadrant you're in, will determine what sign your trig function will have. So quadrant 1. So quadrant 1 is where all of your right triangles would exist, your standard right triangles. In quadrant 1, all of your trig functions are positive. Sine, cosine, tangent, cosecant, secant, cotangent, all of them will give you answers that are positive, as long as you are inside of quadrant number 1. So as long as your angles stay between 0 and 90 degrees, all of your trig functions will be positive. When you venture out of that, that is when things start to change. So quadrant 2, the only trig function that is positive is sine. Well, sine and cosecant, because they're reciprocals to one another. So anywhere, if your angle is between 90 and 180, sine and cosecant will remain positive, but everything else becomes negative. Everything else, when you solve it out, becomes negative. So that's your cosine, your tangent, your secant, your cotangent. All the other 4. Quadrant 3, which is from 180 to 270, that's where tangent is forever positive. Tangent and cotangent. And from 270 to 360, that's where cosine and secant would be positive. So notice that each trig function does get its own quadrant, except for quadrant 1, in which all of them are sharing it. Now, there are several nuts and bolts that explain just why that happens. That's proof that you would get into in pre-calc. They would more or less prove to you why it exists. In your particular case, you just need to know that it exists. So there is an acronym that helps students remember how this chart looks, and it's ASTC. All students take calculus. So if you're going around a circle, A for all, S for sine, T for tangent, C for cosine. Any questions so far? Again, I will make it a point to take 1 or 2 minute breaks in between. I can't control the heat. I can't control how warm the classroom gets. So know that after we do sine, we'll take a 1 minute break, and then cosine will take another minute, so on and so forth. If anything, just to give yourself a chance to stand up and stretch. So in our cases now, we're looking for two answers. We're looking for two answers for every single problem. There are some exceptions, and we'll come across those exceptions as we go along. So let's start with arcsine of -1/2. So remember, arcsine is another fancy word for sine inverse. This is a fancy way of saying sine inverse. So remember, sine inverse of -1/2 means what angles do I need so that sine of it would give me -1/2. That's what that represents. So the first thing you need to ask yourself is, what quadrants can sine be negative in? That would be 3 and 4. So our two answers are going to exist in quadrant number 3 and quadrant number 4. So one of your answers will be between 180 and 270. One of your answers will be between 270 and 360. So now we know where they need to be. Now it's just finding them. So we get one of these for free from our calculator. So our calculator will give us one of them. So we go to our calculator. Again, make sure your calculator is in degree mode. So degree should be highlighted. And we do sine inverse. Sine inverse, -1/2. So we should get -30 degrees. Yes? So we got -30 degrees, but we want to deal with positive angles. We always want to deal with positive angles. So we get -30 from the calculator. How can I force that to be positive? Add 360 to it to force it to be positive. So that's 330 degrees, which puts it in quadrant number 4. So there's our first answer. So there's your first answer. So since we got that one from the calculator, we literally just put calc. Again, the calculator is going to give us one of them. Now we need to get the second answer. So think back to last unit when we dealt with reference angles. Is 330 degrees a reference angle? Absolutely not. Reference angles have to be between 0 and 90 degrees. So we have to figure out, what would this angle be if we were inside of a right triangle? So since we're in quadrant 4, how do we find the reference angle of something in quadrant 4? Say it again. There you go. So your reference angle for quadrant 4 is 360 minus 330, which is 30 degrees. So this angle inside of a triangle is 30 degrees. So that means to go to quadrant 3, we go over to quadrant 3 and we put 30 degrees inside of a right triangle. So now I want to know, what is that angle? How much is that angle? So if we measure it, if that's the 0 line, that's 90, that's 180. If I add 30 more, what does that give me? 210. So your quadrant 3 angle is 210 degrees. So we use the reference angle, we put it in the third quadrant, since that's what we needed, and then we measured off the angle. That's it. You've got your two answers. Problem's over. You got your two answers, problem's over. So before we even look at B, take a second, think to yourself, what part is still fuzzy or what part isn't exactly clicking before we do part B? Anything? Start. How you got the what? So the reference angle, so first we took the reference angle of the answer that we got. 360 minus 330, that's 30. So that's your reference angle. Remember, we were still missing the answer from quadrant 3. So we took the reference angle and copied it into quadrant 3 because that's where we needed it. Pretty much. So we're going to put a 30-degree angle there. Then now we need to figure out, well, what angle is going to represent that? It's definitely not 30 degrees. 30 would otherwise be in quadrant 1. So quadrant 3 is 180 plus another 30 degrees, which gives you 210. Make sense? Sorry, what was your question? So remember, except for certain cases, you will always have two answers. Except for certain cases, you will have two answers. So let's do part B. So part B, you've got sine inverse of square root 3 over 2. Again, first thing you do, find your quadrants. So where can sine be positive? Quadrant 1 and quadrant 2. So we know that one of our answers has to be between 0 and 90. One of your answers has to be between 90 and 180. So that's where our two answers have to exist. So the calculator is going to give us 1 for free. Calculator will give you 1 for free. So let the calculator do its job. So what answer does the calculator give you for free? $60. So the calculator gives you 60 degrees. The calculator gives you 60. Now you have to find the other one. So is 60 a reference angle? Yes, it's less than 90 degrees. So that's it by itself is a reference angle. So that means if 60 is already a reference angle, we can copy it into quadrant number 2. So there's the angle. So that would be 120 degrees. So another way to think about it, if you're in quadrant 2, if you already got one answer, to get the answer for quadrant 2, that's the same thing as 180 minus the reference angle, which was 60 degrees. Just like for quadrant 3, that's the one that you needed, that's 180 plus your reference angle. So remember, quadrant 1, you don't have to add anything. That's already in a right triangle. So there's nothing you need to add. The calculator gave us the one for quadrant 4, but we'll take care of that eventually. Any questions, part B? All right, so part C. Told you that there was a variation that exists, and that's part C. Put C in the calculator and tell me what you get. Domain error. That means it doesn't exist. So sine and cosine has to exist between two numbers at all times. And that's -1 and 1. That's its restriction. So you get anything that's less than -1, you get anything that's bigger than 1, sine and cosine can't take it. Sine and cosine have to exist between -1 and 1. That's their restriction. So this violates the restriction. So that is not possible, no solution. You put whatever you want to put there. Not possible, no solution. You figure it. Use whatever you want to use. Any questions? Example 1 before we take a quick 1-minute break. All right, so we'll do a quick 1 minute. So let's move on to cosine. Well, inverse cosine. So inverse cosine follows the same rules as inverse sine. The chart doesn't change regardless of trig function. So that chart doesn't change. Yes, go ahead, Eddie. Mm-hmm. So that means the y value, whatever you get, whatever answer you get, starts with 0, or has to live between 0 and pi. So that means chances are the first answer that you get will probably be between 0 and 180 degrees. So example 2, we have arc cosine of square root 2 over 2. We follow the same pattern. So remember, arc cosine is the same thing as cosine inverse. So where can cosine be positive? Quadrant 1 and quadrant 4. So one of your answers will be between 0 and 90. One of your answers will be between 270 and 360. So Addie, based off of what you just mentioned, there's a good chance that the answer that the calculator is going to give is going to fall in between in quadrant 1. Now, is it a guarantee? No. But the restriction tells us that it's going to fall in one of these. So, yeah, go ahead. Move the right arrow over once. No problem. So what does the calculator provide to you? 45 degrees, which in your case, Addie, falls within that restriction. So 45 degrees is our first answer. Is 45 already a reference angle? Then that means if 45 is there, then 45 has to go there. So we just have to figure out what is that angle. And it's 315. So it's 315 degrees. So if you're in quadrant 4, if you have the reference angle, a formalistic way to go about it is 360 minus your reference angle. So now you have a formulaic way to go about it for quadrant 4, for quadrant 2, and for quadrant 3. So now you have a formula that you can use. So if you don't want to keep drawing the triangle, that's fine. If drawing the triangle helps you see it visually, then do what you do. There's your 2 answers. Any questions, part A? All right, so part B, part B, I believe, is a variation problem. So arc cosine of -1. Arc cosine of -1. So this time, if you go, well, first off, that's -1. So where should it exist? Quadrant 2 and quadrant 3. So 90 to 180 and 180 to 270. So what does the calculator give you? 180, which is the end of that boundary and the beginning of the other one. So that means it's counting in both of them. So you only have to count it once. That's your answer. So if it's counting in both parts, that means it fell on the axis. It fell on the axis. So that's your 0-degree line. 90, 180, 270, 360. Each of the axes has its own points. So that's 1, 0, 0, 1, -1, 0, and 0, -1. So 180 degrees fell right there. -1 matches up with the x-axis, or x value. And remember, if you were working with a unit circle, cosine is equal to the x value. So it all lines up. So main variation, if it matches, then you only use it once. If it matches, you only have to give it once. So in this case, there's only one answer. Any questions, part B? Then let me shut my mouth for a second and let you try part C. Let's see. So as we're navigating this one, so what two quadrants should this exist in? So we're back in 2. Look, I have no control over this board. 90 and 180, 180 and 270. So the calculator should give you 1 for free. So the calculator gives you 150 for free. So 150 degrees, again, whichever one you get from the calculator, just put calc, that covers your work. Putting calculator covers your work. So is 150 a reference angle? Unfortunately, now you got to change it to a reference angle. So a reference angle for quadrant 2 is 180 minus 150, 30 degrees. So quadrant 3, we need a reference angle of 30 degrees. So there's your angle. So what's the angle for quadrant number 3? 210. So 210 degrees. Again, if you don't want to draw, then the formalistic way of doing it is 180 plus the reference angle. So any questions, A, B, or C? So again, it's not a difficult task. It's just going through the progression. Going through the actual progression. All right. So remember, sine and cosine follows the same rules. Tangent, on the other hand, follows its own set of rules. So in the case of tangent does not have a restriction on it. So it can literally take whatever number it wants. So it can take whatever number it wants, whereas sine and cosine do not have that same privilege. So first thing is arctangent. So arctangent of 0. So 0 is not positive and it's not negative. So that means it's not going to be in a quadrant. There's only one other place it can be then. The thing in the middle, I forgot. On an axis. So it has to be one of those 4 points. 0, 90, 180, or 270. So remember, each of those are governed by points. So 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So once again, the calculator should provide you one for free. So what does the calculator give you? 0. Thanks, calculator. Really came through for us. So that's 0 degrees, which makes sense because tangent's formula, tangent is y divided by x. 0 divided by 1 is 0. So if you look at just those 4 points, what's the only other point that would do that? 180. So there's your 2 answers. So it's not just reference angles that gets used. It's other prior knowledge that you do use to help you find your angles. All right, so let's do another one. Tangent inverse of negative 1. So where can tangent be negative? So quadrant 2, quadrant 4. So one of your answers is 90 to 180. One of your answers is 270 to 360. So I gave you 315. Negative 45, and then you add 360 to make it coterminal. That's not going to work. So quadrant 4, 315, and that's from your calculator. So that's the first answer. So is 315 a reference angle? So what's the reference angle that goes with it? So that's a 45-degree reference angle. So if it's 45 in quadrant 4, it has to be 45 in quadrant number 2. So what angle does that correspond to? 135 degrees. So again, the formulaic, to do it as a formula, 180 minus 45. Hey, bud. Gibson? I only have her for Viking Compass. All right. Questions on B? All right, you navigate C. All right, well, what quadrants are we working with here? So remember, tangent's positive in quadrant 1, and then all students take calculus. We're also in tangent in quadrant number 3. So the answer gives us, so the answer the calculator gives us is what? So the calculator gives you 30, and 30 is already a reference angle. So our quadrant 3 angle should be 210. So 180 plus your reference angle. Again, as I mentioned, if you want to remember the formulas, remember the formulas. If you want to remember the drawings, do the drawings. I don't have a preference one way or the other. Amounts to the same thing. All right. Questions before we take our last break? So the last part that will prepare us for solving equations tomorrow is how do we find a composite value. So a composite value just means we're doing two different operations. So if you use composite values, think composition. Start from the inside and work your way out. Start from the inside and work your way out. So part A might look familiar, might not. That was the extra credit question. So this was the extra credit question, except it wasn't called arc sine because at that point you didn't know what it meant. This was cosine, parentheses, sine inverse of square root 3 over 2. So how you solve it out is you start from the inside and you work your way out. For inside out problems, you do not worry about finding two answers. You purely just use the answer that the calculator provides you. So if we start from the inside, sine inverse of square root 3 over 2 gives you what? 60. And then you do cosine of 60, which is 1/2. So I would rather you use, so if possible, find exact values. So exact values apply when you have 0, 30 degrees, 45, 60, 90. Basically anything that would be on a unit circle. Anything that would be on the unit circle. So side note, make sure you have your unit circle handy from your old notes packet. If you need an extra copy of unit circle, I'll make sure to print some copies and make sure you get them tomorrow. That way you don't have to keep flipping back and forth to the old notes packet. So if it's on the unit circle, then you give the exact answer. If it's any other angle, then you can use decimals. Then you can use a decimal value. So to illustrate that, part B. If you do that in the calculator, you're going to get an answer that's not one of the unit circle numbers. So arc cosine of 2/3 should give you 48 point something. So 48.189, blah, 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 blah. So that's 48 degrees. So since that's not on the unit circle, we are just going to purely give the decimal answer, and that's that. So 1.11. That's it. So for those of you all who are off to the races with C and D, those are probably C, D, and F are the very, very easy examples if you know what those symbols mean. So what does arc sine mean again? That means inverse. So what are sine and sine inverse in relation to each other? Those are opposites. So opposites cancel out. So your answer is 5 pi over 3. So if you have an opposite, if you have a trig function and its opposite directly next to each other, they cancel out. And that's it. Now, I mean, by all means, you can do the work of finding sine of 5 pi over 3 and then taking arc sine of that answer. You're going to end up back where you started. Or, oh, they're opposites. Drop them out, and that's it. Uh-huh. Uh-huh. So arc cosine, remember, is cosine inverse, so that means we're looking for an angle. So anytime you look for an angle, round it to a whole number. If it was a standard trig function, then you go to 2, 3 decimal places. It's only based off of what you're trying to find. So part D cancels out. That's 1/2. So part F cancels out. That's -5. And then part E follows what parts A and B did. So if you have multiple operations, start from the inside, work your way out. So any questions with composites? Because we're finished. So we literally have everything that we need to solve an equation, which we will do tomorrow. So